Hello everybody, this is the recording for the lesson on substituted hydrocarbons. So we just had our online class and I believe I should make a clearer and a much direct version because we had a lot of interruptions during the class. So this time we will talk about substituted hydrocarbons. When we say substituted hydrocarbons, these are families or groups of hydrocarbons that we have started studying in the past year. So we started studying with alcohols, aldehydes, and ketones, and there are other groups than those three. So we will learn later. Okay, before we go to that, let us define these terms, substituted hydrocarbons and functional groups. So look at these slides again, as you have seen this previously on my other lessons. As you can see, the vast majority of organic molecules contain elements, not just the carbon and hydrogen. They also have other additions. They can have aside from carbon and hydrogen, they can have nitrogen, they can have sulfur, they can have more oxygen and more carbons in a different way arranged. Okay, most of these substances are fundamentally hydrocarbons that have additional atoms or groups of atoms called functional groups. The term functional groups, they are interchangeably used in other books, but for this class, we will use the term substituted hydrocarbons, substituted hydrocarbons as the general term for these molecules or for these classes, which are substituted by functional groups. Nana ay functional groups. Okay, as you have studied in your learning material, let me read from you. So this hydrocarbons, which has a substitute of atoms of other elements that are not part of that hydrocarbon, but it was there, it's substituted. These are called the substituted hydrocarbons, and the part of a molecule having a specific arrangement of atoms that is largely responsible for the chemical behavior of the parent molecule or the change in the properties. And that specific group are called the functional groups. So functional groups can be atoms, can be a group of atoms, or a certain bond arrangement. So notice that in the structures here, we can have, for example, in the first one, the red one is the oxygen, and the black one, this is carbon. So it's not just the carbon. This is a special group that you have an oxygen and connected to a hydrogen. So we will learn later what these are, right? So those are, we have different functional groups also. Okay, so revisiting the past slide that we studied in other lessons, we have this summary of all the common functional groups. So still in other books, giterm gihapon siya nga functional groups. Okay, but don't worry because ang ato lang term ani nila ha kay classes or the substituted hydrocarbons, and ang specific functional group kaning naa diri sa ubos ani. Okay, so to read, functional groups is an atom or group of atoms in a hydrocarbon derivative that contains elements in addition to carbon and hydrogen. So mao gyapon mura rin siya interchangeable nga term ang katong substituted hydrocarbon. But again, let me emphasize gihapon ha, kaning families in this column, families ni sila, the classes or the other termed as substituted hydrocarbon. Wrong spelling. Oh, let me erase that. And then substituted hydrocarbon. Okay, so we have general patterns that we will learn later and some specific examples. And for this class, we will not, I will not add you more burden by memorizing on how to name them technically, but we'll just familiarize on the general formula, the general structure, and the functional groups present in each category, in each family. Okay, so functional groups are also important because they are the units by which we divide organic compounds into families of compounds or katong mga substituted hydrocarbon families. So the functional groups are present in a lot of aspects in the living world and in the organic world. So this can be found in our skins, in our bones, in our DNA. It's also found in our food, in the products that we use. So it's all around us, and it's better if we familiarize all these. Okay. So this table that I'm showing you is a table that has specified the names of the functional groups. So kaning functional groups, kani siyang hydroxyl, mo ni siya ROH, methyl, CH3 ra. So carbonyl, lagi siya inana. So carboxyl, amino, phosphate, sulfonyl, and so on. Okay. I also will be showing you this table just to get you know some of the ways these families are named. So alcohols, there's an all at the end. There's an either, for example, as alcohol, ethanol. Either, diethyl ether. Aldehydes na al sa tumoy, ethanol. Okay. And ketones na siya own propanol. Carboxylic acid, oic acid, and then, for example, ethanoic acid. Ang esters, ill-OAte, or for example, methyl ethanoate. So, yes, just a glimpse of how to name these compounds. Now let's go to the specific substituted hydrocarbons / categories / families of hydrocarbons. Okay. But first, we have to familiarize the notation. So I will be showing you the general formula or the general structure. You will be seeing this repetitive pattern. For example, na siya R, na siya R prime, or na ba siya R, na ba siya OH, or na ba siya, does it have R, and then CO, and then R here. So your R stands for, let us read the upper parts here. Here at the lower portion, R and R prime, the apostrophe, small apostrophe, is read as R prime. R prime represent hydrocarbon fragments, which may be the same or different. These substances are also called alkyl halides. So, alkyl halides. Okay, so this refers to any kind of an alkyl. So you can have your R could be CH3, CH2, connects to the CO. And this could be C, and then this, your R could then stand for another CH3, and so on. And then another, you can have, for this example, for this pattern, the R could be CH3, and connected to an O, and then it's connected to another CH3. So it could stand for the same or different. Okay, and also you can have for this pattern, you can have CH3, CH2, CH2, until it's OH. Okay, so your R could stand for any alkyl group. Okay, so these special a special group of atoms, the functional groups and the families that they're categorized into, are what we're going to learn in the next slides. Let's start with halogenated compounds, or the halides. Okay. The structure for this one is R connected to an X. The X stands for any of these four commonly reactive or highly reactive halogens. The fluorine, chlorine, bromine, iodine. Okay, all these four. The common example for halogenated compounds, let us observe this one, the chlorofluorocarbons. When we say chlorofluorocarbons, there is a chlorine And there is a fluorine in that structure. For example, freon. Look at freon. So freon, you have carbon in the middle, but on the sides we have chlorine, fluorine, and fluorine, and fluorine. So this is an example of a chlorofluorocarbon. Then also we have mothballs, and this one, another kind of substance, and we will learn. Okay, some of these are found in kaniyang mga na-freon po dire na mga refrigerants. Okay, so the functional group of the halogenated compounds, or ang naa niya kay mga halogen atoms. The properties, it has high density. So it's used as refrigerants, solvents, pesticides, moth repellents, and some plastic material component. The biological function, halogenated compound, is also found in the structure of the thyroid hormone. Okay, examples: chloroform, dichloromethane, thyroxine, the thyroid hormone, the freon, a type of a chlorofluorocarbon, DDT, PCB, and PVC, which we will see in the next slide. Unsa ni siya mga PVC? Here is an example of a polyvinyl chloride, PVC. So this is a common material that you can see at home. That's one of the pipes at home. PVC ni siya. So naano siya chlorine, kay polyvinyl chlorine. Then DDT, dichloro diphenyl trichloroethane. So duha ka chloro diphenyl, duha ka phenyl, duha pud ka chloro, o tulo ka chlorine, trichloro, then ethane diya pita. So this is a special molecule which is used as main ingredients for insecticides and pesticides. So it kills mga roaches, mosquitoes, ants, fleas, bedbugs, water bugs, etc. Okay. Another example ang PCB. Okay, mga chip boards, computer boards. Ang material po na niya na po ni siya halogenated compounds. Okay, this common example for halogenated compounds are chlorofluorocarbons. So unsa ganila, let's have a short review. How does chlorofluorocarbon destroy our atmosphere? So this is a pollutant. Your chlorofluorocarbon from the materials we use at home, such as mga aerosol sprays. Okay, that molecule, chlorofluorocarbon molecule, rises up until it goes to the stratosphere where the ozone layer resides. This, for example, molecule, as the UV rays causes the chlorine atom to break away from the molecule, this has now a free chlorine molecule. This free chlorine molecule, gitangtang sa UV rays, energized and removed, this can disrupt this ozone molecule, which is composed of is a triatomic trioxygen siya nga atom, or nga molecule, I mean. So this one, it disrupts them, and the chlorine atom pulls one oxygen atom away, so it becomes now a chlorine monoxide, leaving an oxygen molecule here on this side. This free oxygen now, kay naay makakita siya og chlorine monoxide. So mumit na po siya diha, and then it merges again, and then the result is another free chlorine atom, which goes back and disrupts another ozone layer atom. So that's why mabungkag atong mga ozone layer molecule layer. So mauna nga madaot ang ozone layer, makasulod na dili na the UV rays will not be fully prevented from going into the further layers of the earth. So medyo that can cause mga harmful effects, not just on the humans living and the animals, also on the plants, and more contribution to mga heat within the surface, trapped heat, which is not good. Okay, So let's help our planet cool down by using less of the products that have chlorofluorocarbons. Can research more about that. Okay, next group. The first one, halogenated compounds. Next, alcohols. Alcohols, it's not just a common hand rubbing alcohol that you know, or the drinking alcohol that you may have heard but never tried. Okay, so it's not just that, but there are also other forms of substances which we can consider as alcohols. In chemistry, we just refer to them as alcohols when they have this structure of R-OH. This OH is a functional group called hydroxyl group. Hydroxyl group is a hydrogen atom bonded to an oxygen atom, and then this hydroxyl group is bonded to a hydrocarbon of a part of a molecule. So we can have this as polar molecules na mo attract of water molecules. It has a high boiling point, and alcohols with low molecular weights are soluble. And the higher will their molecular weights be, the higher will their boiling points be. Go. Examples. They're used or uses. Uses disinfectants, this one, and then mouthwash, solvents, hairspray ingredient, and antifreeze, polyethylene glycol. Biological functions, reactive groups in carbohydrates. So it's also a portion of the molecule of the carbohydrates, and it's a product of this process called fermentation. So next, examples. We have common examples of alcohols: methanol, ethanol, isopropanol or isopropyl alcohol is a common type of rubbing alcohol in your cholesterol and your sugars. Okay, so you can search more on the properties of antifreeze. I have discussed this one in class, so it's also found in your reading material. Okay, how important antifreezes are. Okay, this is a video that you can watch. I will provide the PowerPoint to the class so you can have the link. Next, carboxylic acids. So another group are the carboxylic acid. Before we go to that, let's have this short, quick study of this insect called the ant. So have you ever tried being bitten by an ant? Yes, we all have. And then, ang kaning ant, it's very stingy. No? Sometimes maburot pa dyan yung kamot. And also, another interesting thing about ants, when you observe them, like ito po mga black ants, they tend to follow one another when they transfer from one place to another. They use this chemical which they call pheromones that they use for communication. And this is the structure of the venom and the pheromones. Naa siya H, a double bond O with a carbon here in the middle, and an OH. So, unsa kaya ni nga double bond O, OH. Okay, let's go. And another type of examples for carboxylic acids is this acetic acid. Acetic acid or kanang naa sa inununan, vinegar. Okay, vinegar. So, the structure is RCOOH. Okay. And then the general structure is RCOOH. So the functional group is what you call a carboxyl group with an X, carboxyl group. Okay. This is COOH. So RCOOH. The other one is a double bond. The other one is a single bond. Ang na-IH usa. On the other side, connect na yun of any kind of a mga hydrocarbon. Properties. Acidic, usually water-soluble, strong and pleasant odors, form metal salts in acid-base reactions. Uses, vinegar, tart flavoring, skincare products, production of soaps and detergents. Biological functions, they can be in the molecules of the pheromones, anti-sting toxins, It causes rancid butter and smelly feet odors. Sa kani mga strong smells, mo ni sila mga carboxylic acids food. We have carboxylic acid even in our sweat. Even ka na mga body odors na carboxylic acid dira ka ng mga baho na tangsingot na carboxylic acid ang naa diha. Some examples, we have acetic acid, formic acid, citric acid in lemons. Salicylic acid, kanang gamit gani kanang alap-up, pawalas alap-up, salicylic acid. This one. Okay, next group, esters. Okay, so we're done with carboxylic acid. Remember lang atong pattern is like this. So RCOOH. Now, in the esters, okay, so the esters have this pattern. The H was replaced by an R. So in your reading, esters are a product of a reaction by carboxylic acid, carboxylic acids plus alcohols. They form esters. Okay, they form esters. So, mauna siya makaporma sila esters. For example, diba, carboxylic nimo RCOH, then ang imong alcohol ROH. So, your R here could possibly replace the H. And this free H would then merge with this one, and mahimo na silang H2O. So, usually, these products always have H2O was included in the results of the reaction. So, it's possible. So, just remember this one now. Carboxylic acids plus alcohols is equal to esters. These are derived from carboxylic acids, which the OH of the carboxyl group has been replaced with an OR from an alcohol, like I mentioned here in the reaction. Properties: strong aromas, volatile. It is used as, okay, basta esters ganing kay artificial flavorings and fragrances. Ester fabric. Biological functions niya. Esters are found in fat storage cells, in the DNA, in the phosphate sugar backbone, in the natural flavors also, and the fragrances. So, mga natural flavors and fragrances, o katong gusto na lang mga artificial flavors and fragrances, esters ang responsable. Si ester. Okay, examples: banana oil, oil of wintergreen, triglycerides, or the fats. Okay, this one is also another example. Let us erase all income slide. Okay, the ethyl butyrate. So the pattern is 8-8. So ano siya? Pineapple's flavoring is siya. So look at, you have this group here in the middle. So this is an R group, this is another R group. Ano siya? Next, we're almost there. Ethers. So mga ethers. Okay, look at this example. So what comes into your mind when you look at this picture? So you might think this is a vaccine. No. So ganing picture, this is I referred to look for a picture of an anesthesiologist holding an anesthesia. So the anesthesia. So ang anesthesia is composed of either. Sa una, labi na sa una nga mga compositions sa anesthesia, nadyo either. Unsa man kaya ni mga either? Okay, the structure of ethers, kay nagagamay na lang, ROR na lang jud. In the middle, it's oxygen. So, oxygen atom is bonded to two hydrocarbon groups. So, iyahada yung functional group kay oxygen na jud ang naa. Okay, properties. Mostly unreactive, insoluble in water, volatile. Insoluble in water, meaning it does not mix food in water. So, lahigid siya. Hindi siya food mo combine. Uses: anesthetics, solvents for fats and waxes. Examples: diethyl ether. Kani. This is termed as ethyl ether or diethyl ether because you have an ethyl on both sides. Okay. Next, An ether is an organic compound in which an oxygen atom is bonded to two hydrocarbon parts of the molecule. The ethyl ether is often simply called an ether, is an effective anesthetic. Because it is insoluble in water, it passes readily through the membranes surrounding the cells. An ether is rarely used now, by the way, rarely used na siya as an anesthetic kay highly flammable and causes much nausea sa mga patients. So, it's harmful to the body. So parang gi-lessen na lang. Or rarely part of the anesthesia. Maybe we can research on kung saan ay naakaroon sa mga anesthesia. Okay. Aldehydes and ketones. So we have studied about aldehydes and ketones before in the past year. And then just a review. So look at this pattern here. Once again, in general structures of aldehydes and ketones. Ketones in the middle. Unsa man yung gi-blue? These are what you call the carbonyl group. So CO. Carbon atom, double bonded to an oxygen atom. So your carbonyl group with an N. For the ketone is in the middle. For the aldehyde is at the end. So R, COR for the ketone, and the aldehyde RCOH. So aldehyde. So what's this vanillin? Is this an example of a ketone or an aldehyde? And that is a tumoy. It's an aldehyde. And acetone in the middle, so mura siya dimethyl. So it's a ketone. It's a type of the ketone. Notice also in the name owns ketone, dimethyl ketone. Properties. It's very reactive, distinctive odor, and it's used as solvents, flavorings, food, manufacture of plastics and adhesives. Embalming agent. When you say embalming agent, what comes into our minds? Embalming agent, formaldehyde. So formaldehyde. It's one of the examples for aldehyde. Acetone food sa ketones. Cinnamon is and vanilla and almond flavorings are other examples. Okay. Formaldehyde is an embalming agent used to preserve flesh of corpses kung maybe will stay for a longer time or preserve it. Okay. Lastly, we have these two groups, two families, amines and amides. Gisagol sila because they have the same category. Amino group ang naa nila. Amino group. Musa kaya ang naa? Okay. Amines, they got their name from the amino group. So, structure for the amine, or amine and amides, or amines. Let's see. For my class, let's use amine. Okay, so RNH2 is the pattern. NH2 is the amino group. And then for the amide, RCOO and then NH2. So you have a carbonyl group and an amino group. So duha. You can simply name this as an amide group. Okay. Functional group. The first one, ang amine na siya, as mentioned, na siya NH2. So two hydrogen atoms bonded to a nitrogen, and this nitrogen is bonded to the hydrocarbon part of the molecule. Amide, it is bonded to a carbonyl group, but na siya CONH2. So technically, this is CONH2. Just name it that way, CONH2 group. It is, the amines are basic. They're not acidic. Okay, amines are strong bases. Example of this one is ammonia. Okay, basic. Ammonia-like odor. Yes. Amides are neutral, but most of them are solids. They are used as solvents, synthetic peptide hormones, fertilizer. Yes. Fertilizer. Commonly, we can relate to this one as a fertilizer. Nylon synthesis. So, biological functions in amino acids or mga proteins sa atong lawas ug sa atong gipangkaon, proteins, peptide hormones, and then the proteins, yes. And other examples, okay, we have urea, putrescine, cadaverine, and nutrasweet. Cadaverine and putrescine, okay, first have putrescine. Putrescine, look at this pattern. See, in the middle, nasa tumoy ang amino group. So this is an example of an amine, na siya amino group, both ends with yeah. Whereas urea, observe urea, na siya C, double bond O, nya, and H2, and then so here muna iyang special group. So this is definitely an urea, an example of an amide. So katry na mag-urea ka na mag-abuno gani sa yuta, o mag-abuno sa tanom, sa mais pa karon. Okay, this is the other structure of molecular structure. Nitrogen is the blue, carbon, and oxygen. Okay, so those are the families or the categories of hydrocarbons, which are specifically called substituted hydrocarbons. So I just hope you do not confuse these families. So let's enumerate them. We have halogenating compounds. Which and the pattern is Rx. X stands for any halogen. Next, alcohols are OH. OH is your hydroxyl group. Next, we have carboxylic acid. Carboxylic acid has a carboxyl group, so R, COH. Next, we have ester. Si ester kay ang carboxylic nalahian na og R. Next, ether. Ether, simple na kayo, R. And what else? Amine. Simple na si amine, R, and H2. Amide, R, C, O, and H2, or R, CO, and H2. Okay, these are the most common of the substituted hydrocarbons. Okay, so where can we find these? The common sources such as the fossil fuels, the coals and petroleum, and natural mga sources. We also have fermentation. So fermentation is one of the processes wherein we can obtain the ethanol. So we can ferment these, for example, kaning mga grapes, if ferment siya, and then we can watch this video. You can watch this video with the links provided over somewhere here, and then you can watch this video on how the alcohols are being sourced out. So there are two of them. You can get alcohols naturally, or you can get them by fermentation and also by naturally. So just to summarize, naturally pwede ra, pero pwede po fermentation. Okay, you watch the video to know about fermentation, and then through reaction with ethene. So it's all there in the video. Okay, links will be provided. Alright, so those are the different substituted hydrocarbons, and that ends my lesson for this afternoon and for this session. This is our last lesson for the quarter 1, or the quarter about organic chemistry. So in the next quarter, we will go to another group another branch of science in consumer chemistry, and that is food chemistry. So I hope you still have the energy to do your best in all the activities that we have. And thank you so much for watching throughout this video, and have a nice day. Goodbye.